last lesson, we worked a problem where we started with an equation that looked like this. It was 3x minus 2y equals 4. And we put this into a form where we solved it for y. And we did that by subtracting 3x here and subtracting 3x here. This became 0. And we ended up with a minus 2y equals a minus 3x plus 4. And then to isolate the y, we divided by a minus 2. We'll divide these by a minus 2. And we get y equals minus 3 divided by minus 2 is 3 halves, positive x. And divide our 4 by a minus 2, and we got a minus 2. And when we had done that, we actually generated some points for this line. This is a linear equation, and we generated some points on this line. And then we found the slope from those points, and we found that the slope equaled 3 halves. And I said at the end of that lesson that when we get a linear equation in this form, this is called the slope-intercept form of an equation of a line. It's the slope-intercept form. This number in front of the x is always the slope, and this is always the value of y where the line crosses the y-axis. So it's the slope, here's the slope, and the intercept here, this is the intercept of the line crossing the y-axis. So the common mathematical expression that is used in the slope interface formula, the slope-intercept formula, is y equals mx plus b, where m is the slope and b is the y-intercept. Now this is going to make our, if we can put equations into this form, it's going to make our graphing process a lot easier, because we'll know the slope of the line and we'll know a point on that line, and that point is the point where the line crosses the y-axis. So let's look at the example in your book and use the slope and y-intercept to sketch a line. So example 7 in your book, in your text, is x minus 3y equals a minus 6. So in order to use this point-intercept, we're going to solve this for y. So we'll subtract x from this side and subtract x from this side, and we have a minus 3y equals a minus x and a minus 6. Notice that all of these are negative numbers. A way to get rid of them is just divide everything by minus 1. If we divide everything by minus 1, we get 3y equals x plus 6. Now we need to get rid of this 3, and we can do that by dividing by 3. And this becomes y equals x plus 6 divided by 3. This is just the product of a fraction. This is the common denominator. So we can split this up into two fractions, x over 3 plus 6 over 3, which is 1/3 x, right? X divided by 3 is 1/3 times x, plus 6 divided by 3 is 2. So notice that we have this in the slope-intercept form for a line. Our slope, m, is 1/3, and our y-intercept is 2. Now let's graph this. We don't have to generate a table. We don't have to go through all that work. We can graph this just knowing the slope-intercept form of the line. So I'll draw a coordinate system here. And I'm going to mark off the grid and use each of these equal to 1/2. So this would be 1, this would be 2, this would be 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And I'll go ahead and number these. 2, 3, 4, 5. That's probably enough. This is my x-axis. This is the positive side. This would be a -1. This is 0 here where they cross. This is a -2, -3. Okay? And this is our y-axis, the vertical axis. This is positive when we go up from 0. So this is 1, 2, 3, 4, 5. And this is negative when we go down from 0 on the y-axis. Now, I'm going to write the equation that we just came up with. We had y equals 1/3 x plus 2. Whoops, let's get it on the screen. Y equals 1/3 x plus 2. This is in the form y equals mx plus b, where m is 1/3, that's our slope, and b is the y-intercept. Well, knowing b here, we know where this line crosses the y-axis. It crosses it at 2. So we know this point is on the line. The line is going to cross here at 2. Now, knowing the slope, we can generate another point, another couple points if we want. Our slope is a positive 1/3. So we'd go up. Remember the slope, m is the slope, and the slope is the change in y over the change in x, which means we're going to go 1 change in the y direction, move 1 up in the y direction, and 3, positive 3, in the x direction. So we'd go positive 1 in the y and 3 in the x. So the next point on this line would be right there. We could go in a negative direction. We could go a -1 and a -3 because negative divided by a negative is a positive. So this is the same as 1/3. So if we went a -1, we'd go down 1 on the y, and a -3, we'd go over a -3 on the x. Notice if I draw a line, it connects all 3 of these points. So using the point intercept or the slope intercept form of the equation, we're able to draw the line for this equation without having to calculate tables and solve for m by taking y sub 1 minus y sub 2 over x sub 1 minus x sub 2. This is a lot much faster and slicker way to do that, although you have to know both ways for the exam. But I just wanted to explain this way to you. Okay? That's the end of this problem.